To Bay Area Search Meetup for tonight. I'm Thomas Penn. I'm in charge of Meetup's speaker invitation. So in case you have any speakers you want to get for this meetup, or you want to recommend any speaker to speak in this meetup, just let me know. We're very welcome for any feedback from you guys. So before we start, anyone want to make any announcement? Anyone? Oh.
My name is Brian Johnson, and I work with Thomas at eBay. And we're hiring, so if you're interested in any jobs, hit me up afterwards. This time I brought plenty of business cards because I knew we'd have a full house because Doug has got such an illustrious career, so we're kind of using Doug for recruitment. And Dice is here, they're recruiting too. If you work at eBay, you're not allowed to go in the Dice bus. No, I'm joking. I'm in the search group here at eBay, Applied Research Group Science, but we have jobs in all kinds of different areas. And I'd also like to take just a moment to, this is the first time we've had sponsorship. We started this about 2 years, I started about 2 years ago. And thank you for Dice for providing all the food and the t-shirts and beers and things like that. So it's very nice, and someone's leaning against the light.
All right, cool. So Doug is a very famous guy. I will try very hard to give a low-key introduction of him. So basically, he's a chief architect of Cloudera, and I think everybody knows that he started Lucene, and now it's Lucene and Solar, and he also started Notch and Hadoop, and that's why he's working with Cloudera now. So let's give our speakers a round of applause, please.
Thank you. Thank you very much. It's good to be here. See some familiar faces in the crowd, folks who I haven't seen since the 80s. The title is Search in Hadoop. Somebody said, what about Lucene? I thought we were going to about Lucene. We're going to hear some about Lucene too. But I think really what I'm excited about these days is getting search integrated into Hadoop. And so I'm going to spend some time talking about that as well. So first up, a little bit of Lucene history. So before I first wrote Lucene, I worked on search engines for a while. Wrote a couple at Xerox. Worked at Apple, actually, writing is anybody here from Apple? Probably not. Yeah, no? Wrote a search engine there that I believe is still used. I was hoping somebody could confirm this because nobody's confirmed it for me yet. In Spotlight. And then I started working at Excite, and got an Excite former colleague, which is just up here. And worked again on a search engine. And in '97, took some time out while I was at Excite. Worked part-time and on my own. Wanted to learn Java and had some ideas about a different way of doing a search, another search engine, and wrote Lucene in the winter of '97, '98. And then just sort of set it aside for a couple of years and went back to full-time work at Excite until it went bankrupt in 2000. At which time I started figuring, well, what am I going to do with this thing? I wrote it. It's probably useful. I think it's cool. So I put it up at SourceForge under the only open source license that I'd heard of, which was the GPL. Immediately people started complaining, saying, this is awesome, but that GPL thing sucks. And I'm like, really? So I switched it to LGPL. I'm trying to give it away, and people are complaining. So that's a problem with the license. If I try to give you something and you can't take it. So LGPL was a little better, they still were complaining, and then 2001, some folks contacted me from this relatively new kid on the block, Apache, said that you should come join us, Apache's awesome, you'll love it. And I was like, whatever, okay, cool. And they said, we got to change the license. I was like, okay, cool, let's do that. And since then, nobody's ever complained about the license. So that's sort of my story of open source licensing, is if you want to give things away, and people are complaining about a license, that's a problem. At least for me. Depends on why you're giving it away. I wanted the software to be used, was my goal. So, you know, at Apache, Lucene gradually got more and more users, became a top-level project after a few years. Solar was donated by CNET in 2006. Became a part of, you know, Lucene, became a part of the Lucene project. Kept improving. I stopped mostly working on it probably around, I don't know, 2004 or something like that. I haven't done a lot of work on Lucene in the last decade. I sort of stayed with it as long as it was needed. As soon as I figured the project was to the point where it could survive without me, I kind of stepped away quietly while nobody was looking. Anyway, so Solar came along, and I was not terribly involved with that. Yannick Seeley was the primary author of Solar. Provided a nice, you know, web UI or web API on top of Lucene, as well as packaged together a lot of features in a simple to use way. Faceting being a huge one, and still it was a single node solution primarily. There were some ways you could replicate Lucene that are still used. Some of which I originated. I'm not terribly proud of them. They're pretty crude ways of replicating a single index. But really doing sharded indexing wasn't something that was solved by Lucene for a long time. I started in 2006 working pretty much full-time on Hadoop. Actually, somewhat before that, probably 2004-ish even. I was starting to work on the predecessors of Hadoop in Nutch, and was really interested in distributed computing and hoped that someday Lucene would get distributed, and it finally did last year when Solar Cloud was released as a part of Lucene 4. Pretty exciting milestone. So now Lucene could be used within Solar Cloud as a scalable, sharded, distributed search engine that you can, in theory, scale to arbitrarily large document collections, as well as to arbitrarily large amounts of query traffic, just by adding more hardware. Good linear scalability in the 2 dimensions that we care about. In the meantime, Hadoop's coming along, doesn't really, handling lots of different kinds of workloads, but doesn't have a good search solution. So this year, with colleagues at Cloudera, we've managed to try to put the two together to give you a search within Hadoop, which I'm going to spend some more time talking about. First, I'm going to back up, talk a little bit about Lucene. Lucene has pretty simple, seemingly obvious architecture. There's sort of some 4 primary components that are reasonably well abstracted and separated by interfaces. At least that was always the goal. At the bottom, you've got a storage abstraction that determines how indexes are stored. Then you've got the indexing abstraction, which allows you to store statistics about documents. On top of that, you've got some means of extracting words, content, tokens, terms, whatever you want to call them from documents, which we call analysis, and search algorithms that work based on reading the index. And this was this sort of decomposition is something I'd been using for a decade by the time I wrote Lucene. The primary inspiration for Lucene was a different approach to doing the index than I had used before. And this is the diagram that I dredged up from somewhere in my hard drive. I don't know when I originally drew this, illustrating the Lucene indexing algorithm. I'll try to walk you through it real quick here. So the idea is, over time, you're adding documents. Those are the things at the top. As you add each document, notionally, you create a single one-document index for it. Now, there's lots of optimizations. This is not exactly how things work, but it's just for illustrative purposes. So you create these indexes, and as soon as, in this case, we're going to say that our merge factor, our magic number, is 3. As soon as you got 3 of them, you're going to merge them together and make a larger index. So as we went left to right, we added this one, we created this merge, and then we could replace those three with that one. Then we do another three, merge to create another three, create another, and now we've got three of the next size up, and we merge those up into one of 9. Right? Hopefully you can see the pattern. Fairly straightforward. And after we've indexed, what do we have? 15 documents here? 14. Somebody can count better than me. We end up with, in this case, 4 indexes to search. And in general, this has some really nice properties. So at the top, all we keep is as a pointer to these indexes that remain. The other ones are discarded. Pretty simple. Some advantages of it is the index is relatively incrementally updatable. You can add new documents as tiny little indexes. The bulk of the index, though, remains in these larger indexes. You can merge things, do these merges in the background. This actually wasn't implemented for years, but now actually merging all happens in the background in Lucene. And algorithmically, you're doing a merge sort. You're doing it in an odd order, the merges. You're doing it sort of in a lazy style as things arrive. But you're optimal in terms of sorting the data and touching it as few times as possible. You're also accessing the data sequentially primarily. That was a huge advantage. So as I said, I implemented indexes, full text indexes a number of times before, primarily using B trees and trying to put lots of caching and batching and things like this layers on top of B trees. But fundamentally, B trees get fragmented, and you end up not doing sequential I/O unless you spend a lot of time defragmenting your B tree all the time. And rather, by doing this thing with flat files and indexes and copying and merging and creating new flat files, you never get defragmented indexes. You're always doing sequential access over indexes and using hard drives and something they're good at, which is transfers, good productive work rather than wasting time doing a lot of seeks. I think that's sort of fundamentally what made this a more scalable method. And it works pretty quickly. Also supports search pretty well. You can search all the segments. You've got a bounded number of segments, which is reasonably small. A lot of them are very small, take very little time to search, and the bigger ones are where the bulk of the time is spent. Small ones can be entirely cached. If you like, you can merge them all together and get one big index. In Lucene, we call that optimization of the index. All right? Am I going too quickly? Have I lost you? All right, I'll speed up. So a little bit about search in Lucene. So the idea was, you could provide different kinds of search modes. Primarily, you wanted to do a good job of ranked search was the goal initially. Rather than just doing documents that match, you want the ones that match better to come first. And also support if you do actually want to sort it by some other criteria like date or type or something like that. Provide that as an option as well. One of the things that was also a little different about the way the query processing worked in Lucene and still works is that the index is streamed through. And a lot of people in other search engines at the time would materialize intermediate result sets for subclasses of queries in memory, and then do the next step of processing. And Lucene never does that, at least never did. As I said, I haven't looked at the code recently, but I assume it still doesn't. Because that's really not very scalable, because you end up using a memory proportional to the size of the collection, rather than just the size of the query. So instead, you're constantly streaming through the index and trying to do so very efficiently. Index is very compressed, but compressed in a way that's easy to decompress for search purposes. You get this great property of not using a huge amount of memory when you're searching. Also tried to add an extensible set of query operators, both Boolean and phrase, Later added ranges, spans. Has anybody ever used a span query here? Hey, there we go, good. It's a cool feature which nobody ever uses. It was fun to implement. Spatial searching, pretty popular these days. Lots of folks are probably using, who's doing spatial searching with Lucene or with Solar? Doing by latitude, longitude, geographic search? No? Yeah, we got some smiles out there. People are using that. So anyway, these have all been operators that have been added over time. The search component is fairly extensible. I'm not going to talk about cache bit filters and things like that. Anyway, so provided a pretty useful set of search tools. But over time, primary thing we've seen, the real value here, is that there's a community growing around Lucene, that this developed and matured. At this point, it's quite a mature community. So, I mean, through the years, not only did we see query operators and different sorts of storage backends added, but we see things like highlighters, search completion, so suggesting terms you might search for, spell checkers, a whole library of tools, analyzers for different languages, all kinds of things that have been contributed by the community. We have Solar, which we already talked about some, got added on top. It's been adopted by a huge number of companies. I didn't mention you guys, but I should put eBay, for example. I don't know how many books. When I found these slides, it said 4 books, and I decided that was last time I looked at these slides was 5 years ago or so. And I assume there's considerably more than 4 books about Lucene these days. And I think all this fundamentally is because it was open source. That's what really got a community around it. People weren't afraid to depend on it because they weren't afraid about a vendor doing something that they wouldn't like down the road. The risk associated with using it was very little. You've got a community that's supporting it. You have a high degree of confidence that the community will survive because there's a lot of people who depend on the software. But moreover, even if it doesn't, the software will never cost you anything. And you can use it and do whatever the heck you want with it pretty much, except for there's a few little clauses. You can't sue people for how you're using it or something. But besides that, do whatever you want with it. We've really seen this community mature and provide folks with that comfort. I've often thought that if I had tried to start a business around Lucene, which was one of my original ideas when I wrote it back in 97, 98, that I probably would have gone out of business, or I'd be a very small player, and it wasn't about the technology. It's not so much about Lucene being technically superior. I mean, I think it's a good technology. I'm proud of it, but I think fundamentally the real thing that's made it a success, and the reason you all are here, is that it became open source. And I think I've actually personally benefited more by making it open source than slaving away at some startup that went bankrupt 5 years ago, which wouldn't have been fun. So anyway, also at the end there, several vendors you can choose from to get support for Lucene and Solar. So now I'm going to move on to phase 2 of my talk, which is talking about, now that we've got this thing, we've got this robust community-supported search tool, we now got a cloud version of it, what's the next step for it? And it seems to me we ought to add it to search. Now, this part should be obvious to you. Why should we add it? Well, search is clearly a valuable tool. You're here because you use search and value search. It makes collections accessible to people who don't know SQL, who aren't willing to wait for some long, slow query engine to return things. Everybody here uses Google or Bing or something on a daily basis. As a society, my kids use Google and Bing on a daily basis. They actually use Google. I gotta say Bing too. They actually mostly search for music and stuff like that, but they do search. So it's just sort of this, everybody gets that. And something I learned a long time ago, back in the Excite days, watching people search then, was people get better at searching. As a society, we have gotten better. In the early days, looking at queries on Excite from 96 to 98, the quality of the query improved substantially. People were using more keywords, better distinguished, in keyboards, more query syntax. So it's clearly a skill, but it's also a skill that everybody's learning, and the broad populace. So it's a great tool. I shouldn't have to ask this question. So the question is then, how do you add it? Maybe why add it to Hadoop in some sense is another question. That one also seems like kind of a no-brainer to me. Hadoop is about storing big data, and if you have a search problem, you kind of by definition also have a big data problem. You've got a bunch of stuff that you're having trouble making sense of, and you need a tool to be able to paw through it. And that's fundamentally what big data is all about. But in Hadoop, we've got a suite of tools besides search that have already been developed. We've got SQL engines. We've got MapReduce for writing your own batch processes over data collections, and so on. Libraries of machine learning algorithms. This rich workbench. And shouldn't search be a part of that workbench? Shouldn't that be one more tool in your quiver that you gotta go after this data with? And that was sort of the inspiration here that led us to trying to make search an integrated part of the Hadoop platform. So you can have just one data set, and search was one option on it, and you can share all these other things. You can share your disaster recovery strategy, share all your security features, share all the management as much as possible. You don't want to be managing two separate systems and have them have different availability concerns. You want to, as much as possible, unify things. If you're going to have the two systems anyway, if you're going to have your data present in a Hadoop system and a search system, wouldn't it be nice if those were just one system and to as large a degree as possible? So what we did was we looked around, and they brought me in from my pasture, we looked at various ways we might incorporate search into Hadoop. Solar Cloud looked like the best solution, and so we've done that. It's another separate set of daemons, a separate runtime, like MapReduce is, like Impala is. If you're familiar with Impala, the interactive SQL engine that Cloudera has generated, and really put together an integrated search solution. It's all open source. As much as possible, we're pushing any new code that we wrote. It's largely an integration project of getting Solar Cloud to work well on top of HDFS. But there were bits of code that we needed to write, and I'll go through some of those in a minute. But as much as possible, we're trying to push those back into the relevant open source projects. And so that really what we've got is just a collection of things that work well together, where they might not have worked so well together before. So there was one element that was, I think, made this not obvious that this worked. So through the years, HDFS has been around a while, and Lucene has been around quite a while, and people had, the word on the street was that you didn't want to put a Lucene index in HDFS and try to search it there. That was hideously slow. I tried this in, before it was called HDFS in probably 2005 or so, and it was hideously slow. And we didn't really think about it. It was like, we'll just copy the index locally, and then it works fast. The local file system is nice and fast. Fortunately, there was somebody who didn't give up on this. A fellow named Aaron McCurry. Do I have his name right? What is Aaron's last name? I know he's going to help me. All right. Aaron had a project called Blur, where he figured out what the issue was. And it was pretty simple. HDFS doesn't do any client-side caching of reads. The local file system has the buffer cache. And Lucene and lots of applications depend on that for decent performance, that the kernel caches a certain amount of I/O and does a good job of it. But if you just added a buffer cache on top of HDFS and used that for Lucene searching, it worked fine. And in terms of indexing, the performance was fine. You don't even need to cache index time much. So we imported this code that Aaron had written in Blur, so an implementation of that storage abstraction I talked about at the beginning, so you could store Lucene indexes in HDFS, tried it and tested it, and it works great. And so then it's a huge change. All of a sudden, instead of having a separate index on your hard drive that you've got to manage and worry about allocating space for, worrying about making sure it gets replicated, worrying about who can read it and who can write it, all this stuff. Once it's in HDFS, the allocation. There's tools to handle quotas and so on in HDFS in a cluster. There's tools to handle disaster recovery, backing things up to remote locations. There's tools to handle authentication and authorization. You're all of a sudden in a much nicer place. Moreover, you can get some benefits. If you've got other applications that want to touch the same data, it's already in HDFS. You don't have to do as much import and export. So that was the huge big step, was getting that storage in there. So now I'm going to go through a few of the things that are involved in putting this together and getting documents indexed. One thing, question about there, yeah.
Is that caching is already built into the HDFS and the latest release?
The caching is actually integrated into Solar and Lucene. There's a directory implementation that includes the cache that's distributed with Lucene. I don't know if that's in a release yet. It's been integrated into Trunk. I think it's in the latest release, actually, of Lucene. There's now an HDFS directory implementation that has client-side caching in it. HDFS clients don't yet generally do caching. I think there are some efforts to try to add that generally. For all applications right now, there's a Lucene-specific one that's included in Lucene.
If I don't use this Solar, and I just use Hadoop, how do I get it?
It's pretty Lucene-specific at this point, the cache. You could, what's that?
Would you mind
Sorry, the question is, if I don't use Lucene, but I want to get a client-side cache for HDFS input, how would I get that? And I was saying that the way it's implemented is fairly Lucene-specific, but you could probably recycle it. I would look in the latest, look for HDFS directory in the latest Lucene release, and have a look and see whether there's an API that you can use more generally. I don't remember enough of the details, but it's a good question. Okay, so I was going to talk next. But also, feel free to interrupt if you have questions. I don't mind being interrupted. Also, we're going to have lots of time at the end. If people have questions, you can wait and ask them then. Okay, so different ways that you might get things into this system. So one thing is, this is sort of a general part of Solar, but it's a pretty handy part, is that Tika is included for format conversion. So we can pretty straightforwardly index PDFs and various other formats of documents to get the text extracted, and we support that. We support all the normal Solar APIs for indexing and for search. In addition, some of the new ways that we added to do indexing is through MapReduce, from Flume, and from HBase. And I'll talk about each of those. As well as we added a new thing which we're calling morph lines for keeping you from having to write the same dumb programs over and over again. And I'll go through that too. So first, MapReduce-based indexing. If you've got a huge collection and you want to index it at one time, say, this is the way to do that. Another common case when people end up indexing with MapReduce is if they've got aspects that they want to have index which change on a daily basis. And they can use a MapReduce job to, for example, if you want to have the set of pages that point to a page, or you want to do some sort of link inversion or some sort of graph process and associate things with the document that aren't actually with that document, but that somehow refer to that document elsewhere. Then you need to do some processing, and that could be something that changes on a daily basis. So this common case is that you actually regenerate indexes on a regular basis, and you have to do that. There isn't an incremental indexing story, and so we do that. We support batch-based indexing with MapReduce, and if you need to do bulk indexing, this is very scalable, very fast way to do it. And you can do arbitrary processing, and it's just in your reducer, you're creating indexes. And you have one reduce task per shard you want to create. A variation on that we support is where you want to do some indexing as a batch with a MapReduce job, and then you want to take those indexes and merge them into a live running system and flick a switch and have them all those changes show up at once. Or you could flip a switch and split to an entirely new index all at once. So it's sort of merging this notion of having an online system that's searching one set of documents and then atomically changing it to a new set. So it's not quite. So we're still doing batch processing, but we're doing batch processing integrated with a live system. So we have this go live switch. Then of course we support incremental indexing near real time. So common way this is used is with Flume. You've got logs or events of some sort, and they're flowing into the index and can be searched and found within seconds of the event actually happening. I don't know how many seconds we're down to, but it's pretty quick. Things will show up. Another way you can do things that are incremental is from HBase. We plug into an API that HBase has for replication and see all the changes made to HBase and can index them as they happen, so that you can have an index that is synchronized with your HBase online key value store. Within seconds of the time you've made a change in HBase, the change is visible in search. So another nice integration. So Morphlines complements pretty much all of these. It's a library that you can add to applications. Now, if you've got, say, a PDF document, or you've got a web page, or you've got some JSON or a log line, or one of these things, it isn't hard to take those and convert those into a Lucene document for indexing, right? You sort of want to say, I want to take this field from the log, and I want to call that the date field, and I want to take this one and I want to call it the URL field, and it's a pretty simple mapping task, but it's kind of some boilerplate code that you end up writing again and again, it seems really simple. It's obviously application specific. There isn't sort of a one size fits all, because different people's logs are different, different people's events or documents or whatever are different, and they want to index them in different ways. So Morphlines is a tool to try to make this as simple as possible. So it gives you a processing pipeline sort of model, sort of Unix-like pipes, where you can take write these scripts. It's basically a big config file, which you can actually include conditionals and various kinds of logics and looping even in this. And your configuration then includes a definition of all the processing pipeline. I'm not going to go into it in a lot more detail. I encourage you to go look at the documentation for it. There's a lot of good examples. Pretty neat stuff. If you're building search engines and you need to be able to modify them quickly, it vastly simplifies that sort of process. So as an example, you could be getting things from syslog, have Flume pick them up, and then there's the Solar Sync, which is the Flume module that we've provided as a part of search to take Flume events and index them. And within the Solar Sync, you can configure it to do some processing steps. You can read it line at a time. You can do some sort of regex matching on the lines, assign fields to different things, and then different parts of the line, and then put them into Solr. Fairly straightforward, and keeps you from having to either write a lot of much harder to maintain scripts or little bits of Java programs or so on. You can just sort of have one config file that defines all of this. Another thing that we've added on the other end on search is we've integrated a search interface into Hue. Who here knows what Hue is? All right, we got a few. So Hue is a user interface for Hadoop that runs in your browser. Lets you browse the file system, lets you look at, submit jobs, look at queues, run queries. It's sort of a nice, pretty interface for Hadoop. Instead of using command lines, it's the Hadoop GUI, if you will, and it's browser-based. The end user GUI. So we added tools to let you do search within Hue. This is a shot from a video on this you can find on the net. I encourage you to search for it. Search in Hue. It's a pretty fun demo of this capability where they start out with just the basic, with nothing configured for this particular collection, and you just get back sort of very raw search results, and then gradually configure it entirely through Hue to do things like the faceting, faceting, to add in the thumbnails, to highlight matching terms, to link to the original document, just to show the fragments of the documents that match. All those sorts of things are relatively easy to add, and you can get them to look however you like. And it's a great demo how this works. Now, you might want to use Hue. You might want to build custom UI, as many people are accustomed to do using Solr. It's easy to do. This is just a toolkit for building interfaces that are effectively doing the same thing you can do yourself if you want, using Solr's XML or JSON APIs. So to sort of sum up the architecture in one picture, we've got the index, which lives in HDFS in your cluster. We've got Flume, which is one way to stream events in and get them indexed directly in real time. You can also stream changes from HBase. You can also do batch indexing, either directly to HDFS and then start up a cluster based on the new indexes, or you can incrementally update chunks of it with MapReduce as well. And then on the front end, you can use the Hue. You can use one of the standard interfaces for Solr. You can build your own interface on top of the Solr APIs. So that's the basic stuff. If you're a user of Cloudera's tools, Cloudera Manager, then you can manage all this. You can deploy it. You can configure it. It's all integrated with Cloudera Manager. You can monitor it. All that goodness. Help to have it coordinate resources, so memory, CPU with the other services you're running on your cluster. These are all things you can configure by hand yourself. Manager provides a convenient way to do that between all the different Hadoop-related services. So a couple of use cases. How are we doing for time? I should wind up pretty quick. I'll go through these quickly. So just to sort of put it all together in your heads, I want to go through some of these. They're sort of hand-wavy use cases. So one thing this lets you do is if you've got a data set that you were searching over in one place and analyzing, say doing alerting or doing some deeper analysis of over in Hadoop, you can now integrate that all into one system. So you can have these different applications which used to be on separate copies of the data, all integrated on one copy of the data. And so it's a more cost-effective way to do things. And not just in terms of hardware, in terms of management costs, etc. It's one fewer system to run. because it's now a part of Hadoop. Another thing we see people doing is taking different data sets that used to be in silos, and people couldn't manage them well. This is a very common use case for Hadoop, and search plays into this very well too. If you've got different data sets, you can now create an integrated search over them. And thirdly, the other side of the same coin is now you can have different applications running on the same platform. So things that used to be used by a system that used to be having a separate service system for doctors, a separate system for nurses, a separate for the insurance agents, can now effectively be different faces on one system, different ways of accessing the same thing. Similarly here, marketing, sales, support, and field can all be sharing the same master version of everything, rather than having their silo systems that they're having to sync things back and forth between. So really providing this integration. We're really seeing, I think in some ways, the future of what Hadoop is becoming. Hadoop is becoming the primary repository for data in enterprises. As these suite of tools get added, as the tools themselves get richer, we're not yet doing transactional data in Hadoop, but give us time. We'll get there. Performance for SQL is already there. Now we've got search. The analytic capabilities are already better than what's available on other platforms. So it's starting to look like a pretty attractive place to keep everything. So I'm going to close with a little status. Search is currently packaged as a separate download. In CDH5, in the next major release, it'll be bundled with it. That's just sort of a matter of packaging in order to get things out in a timely manner. It's currently separate, but it's just going to be a standard part of the platform. Search will just be there. You can download it today. It's all open source Apache license. Lots of documentation. Encourage you to look at that. Mailing list if you want to ask questions about it. Eva's here, the product manager for Search. If you have questions, you can find Eva, the pink. There's an online training you can take in Search. VM you can download, etc. So anyway, we're pretty proud of this. I'm personally very pleased to see that these two things that I worked on at different phases of my life, my career, have come together. I'd always hoped that Lucene would become a scalable component. I don't think I ever imagined it would actually nestle and live within Hadoop as well as we've seen it can. So I'm happy to answer questions, either about Lucene, about Hadoop, about Avro, about anything else. I think we've got 15 minutes or so to do that. We've got mics if people want to grab those. Otherwise, I'll try to repeat questions after people ask them. Yes?
How does HDFS Federation is going to help some of the bottlenecks that we saw?
How is HFS
Federation?
Federation? Yeah. Federation is really about, the primary use case for Federation is if you've got a really big cluster and you've got more blocks than can be stored in memory. So HFS requires for each 100 megabytes of stored, it requires 16 bytes or so in memory on the name node, round figures, as variables. For 20 node cluster, for 100 node cluster, not an issue. You can get, the RAM on the name node is not a problem. If you get to 1,000 node clusters and you tend to have lots of small files, it can be an issue. If you're trying to build a 10,000 node cluster, it's definitely a problem. And you need to federate the name node so you can have, you can segregate the namespace and have different parts of it stored in memory, different things. That's the primary use case I've seen for federation. The name node hasn't been demonstrated to be a bottleneck performance-wise, which would be another advantage of breaking it up into multiple nodes. And so far, that's the primary one, and it's not a real common use case. I don't know how often we see customers deploying Federation in the field. Somebody might have a better sense of that. I don't think it's very often. And you have to have a pretty large cluster to run into that, and be maxed out in the amount of memory you can put in your machines on your name nodes already.
I wonder, you said you're planning to add transactionality, right? And there is a CUP theorem which says it's quite hard to add transactionality to a system like Hadoop. Could you tell a couple of ideas around that?
I didn't say I was planning to add transactions. I just said I thought it was inevitable that we see, I think it is inevitable, that we'll see transactions implemented in Hadoop systems. I predict that, my bold prediction. And I look at the Spanner paper from Google where they talked about, it's about a year ago, published a paper about how they've done implemented transactions in globally distributed databases, so across data centers. And the way they do it is with, I don't know if you've seen that paper, they do it with very precise clocks. You put a couple of GPS receivers and atomic clocks in every data center, and then you can know what time it really is and what really happened before what, and gives you sort of some ground to reason on, and can effectively do transactional work. And Google moved and now does all of its, I believe its ad sales system is now distributed globally using Spanner. So they've replaced their biggest transactional system with this kind of technology. So it can be solved. I think there's some limitations in how it can work, and it may not do everything, but I think it does enough that that a lot of workloads that you wouldn't have ever thought of putting in these kinds of systems will be moving here. Now again, that's speculative. It's not shipping today.
They just released the F1 paper. F1 relies on Spanner. Like at Google Research, they just released, you could find the F1 paper and it gives more detail.
I haven't seen that one yet. Did that just come out?
Yeah.
Okay, that's great. I'll look for that. So F1 is the system that they talk about that in the Spanner paper. Is the system on top of it? He's got it here. All right. Was that a leading question?
On paper, even.
Right here.
Yeah.
Hi, my name is Heen Liu, and I work at LinkedIn. What you went through is pretty exciting stuff, and I can't wait to get my hands on it and try it out. We basically wrote an equivalent of indexer in MapReduce, so I can't wait to see how that was done in your solutions. I was wondering if you could talk about how you solve, or how does it solve incremental update of indexes? Is that solved through this solution, or is it solved through Solar, or how is that problem being solved?
Basically, we're running Solar Cloud with the indexes stored in HDFS. That's fundamentally what we're doing. So we solve it the same way that Solar Cloud does. And Solar Cloud supports near real-time search, and we're just building directly on that. So the primary component we've added there is just the storing the index in HDFS, which is pretty transparent. Yeah.
Yeah, could you talk about your prediction on the evolution of Spark?
I didn't make one of those, did I? I'm not a real Spark expert. Seems like neat stuff. I think it's getting integrated into Yarn. And so I think we'll start to see people using it more. If enough people start using it, Cloudera will start supporting it and add it into CDH eventually. That's the way things have traditionally entered CDH. That's how we got in the HBase business. When Cloudera started, we're like, no way do we want to support HBase. That's too hairy. And then all the customers were like, we need HBase. So we hired some HBase experts and started supporting it. And I think the same thing could be true of Spark. So we're definitely watching it. We don't want to start adopting technologies that people aren't using. We'd rather other people sort of prove their utility a little bit first. In a lot of cases, and there are cases where we're also more speculative and developing things in-house and pushing on particular directives. Impala was an example of that, where we didn't see the community coming up with something. But Spark is an example where the community's come up with something pretty cool, And if it seems to be the version that people want, then we'll end up supporting it.
Would you comment on the history, why you started? Would you comment on the history, why you added search onto Hadoop, and what triggered that, and where you see it going, especially this as a tool to retrieve information versus some of the analytics and other type of retrievals?
So I think that, the reasons are relatively prosaic. It's to some degree, we had time, we sort of knocked some other things off and had a little breathing space where we could think about, okay, what do we want to add to the platform next? Solar Cloud coming to maturity and Elasticsearch, there were now two things to choose among. And so it seemed like, well, this is something we don't have to build from scratch that would clearly be useful to customers. And they're right now, they're something over on the side. And I think that the spark to me was really seeing what Blur had done, which is, so Blur is yet another system. It's younger than either Solar Cloud or Elasticsearch, doing distributed search, using Lucene on top of, in this case, on top of HDFS. And Blur really demonstrated that it was possible to do on top of HDFS, and we thought, well, that would really be neat. So it was just putting the pieces together that were out there and having the resources to try to build a product out of that.
Who first? Search originally started in some select specific companies who are providing search for general audience. Right now, I think it's fair to say that many people here are using search in their organizations for many other different things, like for anything. So, and since probably somebody wants to learn more how to use search within an organization, could they identify kind of patterns of how Hadoop and Lucene, in particular, this pair, is being used, can be used, supposed to be used, patterns how to use them.
Yeah, so I tried to outline a couple of those. We have some customer use cases. I don't know how many of them we're supposed to talk about. Eva's probably better. She's the person who knows which customer use cases we're allowed to speak about and which we're. So I encourage you to talk to Eva about that. But we've had it out in the field for 6 months now. How many different customers do we have actually using search now?
So it's been in public beta for the last 3 months.
But before that, it was in private beta for.
Yes. So overall, I've seen. Okay. So we've been in private beta since March this year, and then public beta since June. And overall, we've seen, in the tens of customers participating or users participating, providing feedback and helping evaluate the solution. And it's been great feedback so far.
So we've seen. So those are sort of paying customers, I imagine mostly.
It's also users out there.
Users who are just.
We've seen users from Saudi Arabia and from Europe and from Russia. It's been all.
And we've had downloads from over 1,000 different IPs, I think.
Yes.
So it's people are certainly playing with it. Some are actually using it. Is anybody in production at this point?
I have one client who has revealed that they're going into production in 2 weeks.
So it's getting used. So Eva's the person who's been working with all these different folks and knows all the different how the use cases. I think most of them are not consumer facing. Some of them are. It sort of varies a lot from use case to use case. The size of the collections, the complexity of the documents, complexity of the queries. As people know with search, it's all over the map. What people do with it.
Doug? So there's a lot of complexity in Solar Cloud around replicas, all of that kind of stuff. Did you get any simplifications out of just hosting it on HDFS, which should deal with a lot of those kind of issues? Or is it just, let's take it,
yes and
change
no.
the directory?
Yes and no. In some ways, a lot of it's simpler because you're not maintaining multiple replicas. On the other hand, we're not at this point letting you scale traffic by providing a replica of a particular shard. You need to add more shards to scale traffic, and that's one of the features of Solar Cloud that's disabled in this configuration. It's actually, you can use it, but you're going to end up with another copy of the index in a different part of HDFS, which isn't really optimal. So that'll come around in the next version. And we expect it to be considerably simpler than the solution in Solar. We expect to not be using most of that logic, which is awfully complicated. And there should be something a lot simpler if you've got a version that you can all agree upon that's in a shared file system. But we haven't completely cracked that nut yet. That's on the to-do list.
Hi. Just two questions. One was, why did you guys make the decision to go with Solar Cloud, as opposed to Elasticsearch for this solution at Cloudera? And the other was, since I work in the search space, I get the question a lot. Enterprise search, what is the cutoff between, this is really not an interesting problem for you to solve with Cloudera, and more traditional approach of let's get the index on a traditional file system makes more sense. Is there a scale that you could perhaps give us some guidance, because we're a consultancy and we're getting questioned now about what's the benefit of going with Cloudera?
Okay, you asked me two questions, which means I have to remember the first one.
Elasticsearch versus Solar.
Elasticsearch versus Solar. So we looked at both closely. We talked to developers from both. Each seem to have its pros and cons. Elasticsearch is a good product. It's younger, it's cleaner because of that, but it's also less mature and less full-featured. Less people know it. There seemed to be a toss-up. Then we thought about what can we support, and Elasticsearch is an independent company. They're going to control all of the changes and commits, presumably in the interests of their business. And not necessarily in the interests of others' business, whereas Solar is an Apache project that we could, get committers on. We have committers involved in the project and have have greater control. We don't really want to have something that's a core component that we can't easily fix without potentially forking or something. So it was a community aspect that we feel comfortable with. Apache projects and didn't want to trust our fate to somebody who has different incentives than we do. So that was part A. Part B, how big? I don't know if it's so much a big question. It might be to some degree. You've got a small index, then you probably can get away with just doing it on one server, maybe having a backup that hot spare or something like that. And you probably don't need anything terribly sophisticated. So as it gets bigger, it becomes more of an issue. But I think it's more about the integration. If you're already thinking about using Hadoop for other things, then you sort of can have this one-stop shopping, get this integrated experience of search as a part of your larger system that you're already deploying. The same people running those machines, making sure they're up, managing the data center, all that kind of stuff. You get these economies when you're using search in Hadoop rather than separately. You've got a separate system to maintain and run, and it's just that's expense, that's hassle. Instead of something you just click when you configure and it gets installed, and you start indexing and searching, because you've already got if you're already running Hadoop, then all the hard work's done. You've got the hardware, you've got somebody who's administering it who knows how to do all that stuff. Anyway, it's just I think primarily convenience and a consolidation story. There's also efficiencies if you're indexing from HDFS. If you want to use MapReduce, you're going to keep the data in one place. You're not going to be moving it from one part of your data center to another. It's all going to stay within the Hadoop cluster. So there are performance efficiencies as well as sort of cost efficiencies and management efficiencies in keeping it all together. So I think that's probably more of a factor than size. Size is, when are you going to start using Solar Cloud, versus just a single Solar node? Quick question we often get is when should we start using Hadoop? My sort of general answer there is when you've got more data than you can easily process or process quickly on a single node. And usually there's kind of this threshold where you're going to go from 1 to 10 is probably the smallest Hadoop clusters that people. I mean, people will do 4 and 5 node clusters just to evaluate and do proof of concept and stuff like that. But if you're actually going to get some utility from it, you kind of want the 10x. And so there's a little discontinuity there. But that's also you can build a really beefy single machine these days. A lot of processors, a lot of drives, a lot of memory. And with Hadoop, if you're going to have 10, they're going to be 10 far less significant machines, and not cost necessarily that much more than one really beefy machine. So that sort of softens that discontinuity for when it makes sense. But so there's definitely a size aspect as well.
So,
I can't do it. There you go.
traditionally with the search indexer, we've always considered it as an eventual consistency model where we send the updates in a messaging channel and it goes through makes it to the search index. And so with Solar 4, Solar Cloud, high availability, do you think we should attempt to do a synchronous update from the source of truth, say OLTP database, directly send it to the Solar index and take out that messaging channel from the middle, and because it has near real-time capability and Solar is much more available now?
I think you could. I think yes, I definitely think you could. I mean, little hesitant. You're relying on that system to remain available, but you're already relying on the queuing system to remain available. And Solar Cloud and HDFS should be every bit as available as a queuing system. So I don't think you're actually losing anything there. So I think you definitely could. Good question.
Yeah, I got a question. You're starting to bundle things together. I'm thinking about how we build a search engine here at eBay. A lot of what people are interested in is ranking, machine learned ranking, query rewrites, things like that. When you start putting everything in Hadoop, presumably your query logs are in the same place. People are doing a lot of machine learned ranking. This probably isn't something that you guys are going to do, but what do you see as sort of a third-party add-ons in the future for things like this? Like a lot of this query rewrites type stuff, that's what I work on here.
Right.
When I see people doing enterprise search and stuff, they don't have the resources to go crawl through their logs, find all the synonyms and the acronyms, what are the substitute terms that people use for the products that they've got. What do you see as an ecosystem for that? Because a lot of people are doing that kind of stuff themselves.
Yeah, I think there's a lot of opportunities for things like that, to take search and improve it with various kinds of batch processing. If you look at the sort of production systems that you're running today, and that a lot of people are running these, where you're training models and republishing indexes on a regular basis, that's not what Cloudera does. So we're definitely going to depend on third parties to build those kinds of things, whether they're open source or proprietary. We'd love to see them. I kind of think, and I hope we're opening the floodgates here for that kind of thing. That they really, people have been doing things like that, but they've had to do it in separate systems, and it's hard to write a single program that can depend on both Solar's API being there and MapReduce's API being there, and having a single user talking to both, and now you can do that. And so it's possible to build those kind of libraries pretty easily. You've got all the APIs in one place.
I mean, a lot of what we do is we're doing behavioral log processing of search logs, and if we're looking for potentially query rewrites, we might want to evaluate them. So we might want to run them in Hadoop against an index to find out how does it change the document set that comes back, and do things have similar distributions.
Yeah.
Now you could make it all in one place.
Definitely, and I think so. When we started this, my prediction, I don't make a lot of predictions, but was that once this got going very far, people would say, "How did we ever use Solar without Hadoop?" I really think it's a natural fit. That the sorts of people who have search problems are going to have other sorts of things that they want to do. They're going to be these kinds of libraries that people build on top, where they're doing sorts of analyses that feed into the search, and it'll become sort of the standard way that Solar is deployed, and that search won't be thought of as something that's a standalone system on the side so much. We'll see. You can come back in 5 years and tell me I'm wrong. Yeah, we should probably, yeah, I don't know how long people really want to stay. I don't want to keep people here too long. So how are we doing for time?
Let's do last two questions.
Last two questions, okay.
And regarding the future direction of the Hadoop, you just answered my first part of the question. Search being part of the Hadoop.
I really think, I think it's here to stay. We'll see. I mean, it's still a pretty recent announcement. I think it has yet to be fully digested by the community of Lucene. I mean, there's a big Lucene community out there. You guys are, a lot of you are probably members of that. And I think it is a different way of thinking about things. But I think over time, it's going to become a dominant way. So.
My second part of the question is, one of your earlier presentation, you did mention that Hadoop being a kernel and there will be applications built around it.
Being a kernel?
Yeah.
Yeah.
Do you think the future direction, like search, some of the functionalities like event processing or built into the Hadoop itself, or you want it to be a separate entity like a kernel?
I'd say built onto rather than into, but yes. I mean, I think we'll see more and more integration of systems like Storm into Hadoop. I think that the Lambda model there that's used in Storm is a great one, where you've got some background processes rebuilding models periodically, and then you've got some things that are being updated incrementally, so you can present a consistent view that's updated, scalable, updated in real time. Anyway, and I think there's huge potential for that kind of stuff. Definitely.
Last question.
Yeah.
So your product with Solar with index on HDFS
Yeah.
versus Solar Cloud with sharded indexes.
Mm-hmm.
Do you think there's a difference in reliability? Because we are kind of trying to use Solar Cloud with sharded indexes. We don't have HDFS usage. Is there any concern there in terms of with Zookeeper and the sharded indexes?
I don't think there should be. I mean, HDFS is highly available. Zookeeper is highly available. Solar Cloud is highly available. So no, I don't think there should be any. And in some sense, you're leaning more heavily on HDFS and Zookeeper. Well, Solar Cloud's already dependent on Zookeeper's availability. And I think, as we talked about earlier, you're leaning less on Solar Cloud's replication than you are on HDFS's, which is, I think, more mature. It's been around for more years. I don't mean to say anything bad about the Solar Cloud network. I think that's fine too. I presumably it's working well for you, but I would think it would be as or more reliable.
Okay, thanks everyone. The speaker will stay a little bit longer, but before that, let's give our great speaker a round of applause.